Welcome. Welcome to this call, to rush or not to rush. My name is Hubert Chanson from the University of Queensland. I will start by two key questions. A Froude number equal 1 mean critical flow condition, true or false? The Froude number is derived from energy considerations, true or false? The Froude number is a dimensionless number related to gravity effects, often relevant in open channel flow, and typically defined, also not always, as a ratio of a velocity scale to the square root of a gravity acceleration times a length scale. It is named after an Englishman, William Froude, who used it in the 1870s. But strictly speaking, this number was first introduced by a Frenchman, Ferdinand Reech, who was an academic staff at the French Naval Academy, and introduced his dimensionless number for testing ships and propeller, first in 1832 in his lecture note, and subsequently for a journal publication in 1852. At about the same time, this dimensionless number was recognized as important to characterize different open channel flow regime. And in France, the number is commonly called the Reech-Froude number. Possibly one of the first key messages today is that the Reech-Froude number may be derived based upon several different fundamental considerations. First, using dimensional consideration with the use of the Pi-Buckingham theorem. And the Froude similitude is indeed relevant to free surface flow because gravity effects are important. Here you see a photograph of a 20:1 scale model of a ship. Don't be fooled. This ship model weighed between 5 to 8 tons. Another derivation of the Reech-Froude number is by expressing in dimensionless form the specific energy and minimizing the specific energy at critical flow condition following Boris BAKHMETEFF. A further consideration is momentum consideration, either in an integral form, such as the Bélanger equation, or in a differential form, such as the Navier-Stokes equations, with in front of you the traditional Bélanger equation for hydraulic jump in horizontal, smooth, rectangular, prismatic channels. A further derivation is based upon energy, either in an integral form or in a differential form, and many would be familiar with the differential form of the energy equation used in open channel flow called the backwater equation. So my second takeaway message today, the Reech-Froude number may be derived as within from several different fundamental principles, and in turn, there exist several different definitions of the Reech-Froude number. With a few examples here in front of you, and I know at least 4 other definition of the Reech-Froude number. So in that context, I think we need to ask ourselves a key question. What is the most relevant definition of the Reech-Froude number for hydraulic and flood modeling? The answer is straightforward when we think about it. In open channel flow, the most pertinent expression of the Reech-Froude number is the ratio of the velocity to the square root of the gravity acceleration time, the ratio of the cross-section area to the free surface width, where both A and B are measured perpendicular to the streamlines, perpendicular to the flow direction. And in this expression, the ratio of the cross-section area to the free surface width is considered as a relevant length scale. Interestingly, this definition may be derived from both energy and momentum principles. With this definition, and only with this definition of the Reech-Froude number, the Reech-Froude number will be equal to unity at critical flow condition when D equal DC, the critical depth, and the specific energy is minimum. Similarly, when the water depth is greater than the critical depth, and hence the flow is subcritical, the Froude number will be less than unity. And when the water depth is less than the critical depth, that is, the flow is supercritical, the Froude number will be greater than 1. The concepts of critical, subcritical, and supercritical flow are essential in open channel hydraulics. On one illustration is this spillway operation with a subcritical tailwater condition, a hydraulic jump, a supercritical flow down the steep chute, and of course, critical flow condition at the spillway crest. Now, this particular video was taken about 2 weeks between the peak of the flood. At the peak of the flood, my vehicle would have been underwater, and in fact, the weir was fully submerged. So coming back to the beginning of this talk, Froude number equal 1 mean critical flow condition, true or false? The answer is false, unless we define the Froude number using the definition shown here with the ratio of cross-section area to free surface width being the characteristic length scale. The Froude number is derived from energy consideration, true or false? I will say false, because we can derive the Reech-Froude number from momentum consideration as well as dimensional considerations. So really at the end of this talk, the key outcomes are the Reech-Froude number is a dimensionless number, and there are several different theoretical derivations, all of which being correct. But in turn, there are many different definitions of the Reech-Froude number, among which only one is directly relevant to flood modeling. For those who are interested, here are some relevant bibliography. Thank you very much.